Okay, here we are, ready for class on April 14th, Tuesday. Today, what I'm going to do is focus on your questions. So in our last quiz, a lot of you answered the questions about what do you need more help with, what are you confused about? And so that's what I'm going to focus on today, helping you with that confusion so that, hopefully it clears things up enough that you feel more confident in proceeding. And so we'll answer questions this week, and we'll do some more with that survey, and we'll do a smackdown on Thursday. And next week we'll start looking at, or finish actually all next week, we'll look at chapter 11 and some of chapter 12. Okay, so for today, we're going to look at questions about the null hypothesis, questions about type 1 and type 2 errors. What is it? What is this about retaining, rejecting, accepting, all of that with the null and the alternative hypothesis? What is the alpha level? What is P? Those sorts of things. All right. So this, I'm hoping, is review for some and clarification for some. It should not be new material because we've gone over this. So the other thing to remember is you're going to be continuing your draft proposals. So I'm not giving you as much this week so that you have time to work more on that draft of your research proposal. So I need them by Friday. I definitely need them by Friday because I need to have the time for me to be able to carefully look through them so that I can help you while you create your final research proposal. Okay, so I need the time to do it. That's why I need it by Friday. So then you have the time to have it back in order to finish it for April 30th, which is the new due date. Okay, so let's talk about the null hypothesis, right? So when you're looking at a null hypothesis, you have to have a study that has a hypothesis. So like a review of the literature doesn't have a hypothesis. And so in that case, that might be an article that's a review article, but it's not going to have a hypothesis attached to the review. So there's no point in looking at what is a null hypothesis for that kind of article. However, for most articles, you're running some sort of a study, whether it's experimental or quasi-experimental or associative, there is some hypothesis involved. Now, the author may not openly state what the hypothesis is, but you can figure it out from the introduction. Generally, they're pretty clear about here's what we're thinking we will find, here's what our hypothesis was. Not all the time. So you look at what the authors are saying. What is their hypothesis? Their hypothesis is what we call the alternative hypothesis or the scientific hypothesis. The reason it's alternative is because it's alternative to the null. The null hypothesis is that there is no effect. I'm doing this study and it won't work, or whatever I'm looking at will have no relationship. That's the null hypothesis. So the null hypothesis always assumes boring, nothing, you won't find anything. There's nothing to see. Nothing to see here. Move right along. This is dull. This is null. Okay, so that's the null hypothesis. The alternative hypothesis is the alternative to the null. Sometimes we call it the scientific hypothesis or the study hypothesis. You might see that. Okay, so when you set up your statistics, what you're trying to do with statistics is disprove the null hypothesis. So what you're saying is, okay, we got these results. Now, if the null hypothesis was true, what are the chances we got these results? Okay, so if it's like, well, if the null hypothesis is true, and the chance that you got these results, if the null hypothesis is true, is like 50%, it's 50% likely that you get these results. There's no way you can say, well, then maybe the null isn't true, because it's like, well, half the time you're going to get those results. So probably the null hypothesis is the hypothesis that you would retain. You never accept it, though. You never accept the null because we're always thinking maybe our study wasn't perfect. Maybe we don't know. We don't trust that what we see is the null, okay, if that makes sense. Okay, so we assume it statistically, and we try to disprove it. We disprove it by saying the chances of this happening if the null were true are so slim that the null, I don't think the null is true. We're going to disprove the null. Okay, so you either reject the null or you retain the null. You don't accept it. And I know that sounds like it's just semantics. It's just wordplay. I understand that. Retain the null and accept the null seems similar. That is confusing. Just remember that as scientists, you're skeptical all the time, and so you never accept. Think about that. You're skeptical, so you never accept. You either reject the null, you retain the null. Like, it's sort of like you're not really willing. You just kind of say, okay, well, I guess I don't have enough evidence to reject it yet, so I will retain it. That's the idea here. So you just have to learn there's a difference between retaining the null and accepting the null for the purposes of this class. Just kind of radically accept that that's what it is and think, okay, this is a logic issue. So the assumption we're always making is there's no way to conclude that a null hypothesis is true. So remember, we're skeptics. We don't believe that the null is necessarily true. We're just looking for evidence. And we're either getting evidence that makes us want to reject the null or evidence that says, okay, we have to retain the null because we don't have enough evidence to reject it. That makes sense. Okay. So the null hypothesis basically says you have these two groups and the difference between the groups is 0. The difference between their two means is 0, or the association that they have a 0 association, a 0 correlation. That would be the same kind of thing. And so if you have two means and you can't show that between those two means the difference is not 0, it's not the same thing as saying that the difference is 0. So this is like a logic game. Just because it's not 0 doesn't mean that it is 0. Okay? It's just, you just have to kind of wrap your head around that. And if it's hard to wrap your head around that and carry it with you, then just write down this idea that, you know, and so what I did was I copied this particular part of the PowerPoint. I copied all today's PowerPoint for you so that you can go through it again and kind of make sure that your thinking is clear as you read through this. I'm trying to do a lot of explanation with different ways of wording it, so hopefully that will help you. So I like this example. Let's say I couldn't find any chocolate in my daughter's room, right? So that doesn't mean that she doesn't have any chocolate in her room. It just means that I couldn't find it. So I can't accept the null. So if you think, okay, the null hypothesis is that she literally has 0 chocolate in her room. Can I accept the null? No, I can't accept it. It might just be that I can't find it. So we don't assume that we know anything. We're skeptical. We're skeptical that there's no chocolate in her room. The null hypothesis is there is no chocolate, but we don't accept that. And so maybe it's easier to remember when you think about looking for chocolate in somebody's room. All right. Yet, we might make an error. So let's say I go looking for chocolate in my daughter's room, and there is chocolate there, but I don't find it. Then I made an error. My study of finding chocolate was a study that was based on an error, not a study that told me about what the truth is. And so we're looking at two different kinds of errors, type 1 error and type 2 error. And so basically, when you make your decision based on your data, you get your data, you look at it, and you say, okay, the chances of getting that data, if the null were true, are like slim, like 5%, right? So then when you make that decision, it might be that your data was error. It wasn't real data. It wasn't collected well. It wasn't studied well, or it's just probability, just like random chance gave you these results. And so the results don't match the actual truth. Now, of course, remember, as scientists, we don't know what the truth is, and we're skeptical. So we're back to that. You don't know what reality is. All you know is what the evidence points to. So you look at the potential for either of those realities to exist, and that helps you understand what error means. So in this example with chocolate, either there is chocolate and that is reality, or there is no chocolate in my daughter's room and that is reality. One of those two realities is the truth. I don't know what the truth is. All I know is what my study tells me. So I go in the room and I look for the chocolate. That's my study. Do I find the chocolate or do I not find the chocolate? So if there is indeed no chocolate there, and that's the truth, which of course I don't know, and I can't really know. If there is chocolate there and I find the chocolate, then you would say, all right, well, your study was accurate. Or if there's no chocolate there and I don't find any chocolate, then you would say, well, okay, your study is accurate. Except, remember, we are skeptical and we don't know. So all we have is potential error. So you want to make sure that your study will find it if it is there. You want to make sure your study won't find it if it isn't there. So here with this example, the reality is that she does have chocolate in her room. I look for it and I don't find it. Sad me, right? But since it is there and I didn't find it, I have a type 2 error. So this is a false negative, a false negative. It says it's negative, but the negative result is false. So false negative. That is a type 2 error, false negative. And so there is chocolate there, but I didn't find it. Type 2 error, false negative. Let's say, on the other hand, that the reality is that there is not chocolate there. She doesn't have chocolate. That is the truth. I look for chocolate. Now, if I look for chocolate and I don't find it, then what I'm doing is I'm retaining the null, because I can never accept the truth that there's no chocolate in her room. It's unacceptable, right? So you can kind of think about it that way. But let's say I find something that looks like chocolate. It looks like chocolate. It kind of smells like chocolate. It might taste a little bit like chocolate. It's carob. Okay, so I look in my daughter's room for chocolate. What I do find is carob, and I mistakenly say, yes, I found chocolate. That's probably before I really tasted it, right? But I look at it and I'm like, oh my gosh, see, there's chocolate. But it isn't chocolate. That's not true. And so that's a type 1 error. This is a false positive. So a false positive is a type 1 error. A false negative is a type 2 error. Hope that helps. So what you want to do when you're setting up a study, when you're designing and doing research design, you want to set your study up so that it has the best chance of finding the effect if it is there. You want to avoid a false negative. You want to avoid a false positive. Make sense? You want to set your study up so it has all of the elements of internal validity that are going to make it be as strong as it can be. If you're doing a study on an intervention, you want the intervention to be as strong as it can be so that you can see the effect if there is an effect. Okay? So you want a low probability of it. let me start that over. If you're not finding it, if you're avoiding a false positive, you want to have a low probability of finding something because you don't want a false positive. And so the thing that you find has to be so clearly not by chance that the probability is low enough that you would have found it by accident. And so that's why we say we set it at 5%. That's why we set P at 5%. Because what we're saying is 95% of the results would probably be in the same hypothesis as the null, that there is no effect. And so if you find out that your numbers are so different from the null hypothesis that you would only get them by chance 5% of the time, that is why we set P at 5. That's why we say, okay, well, they're so different, you would only find those 5% of the time. Therefore, that null hypothesis is not accurate. So we're going to reject the null. We're not going to retain it. We'll reject it. And so, like I've mentioned before, then what you have to do is you have to do the study again. You replicate. So you do the study again a few times. And if you keep getting those same results that are in that 5% likelihood, if the null was true, it's 5% likelihood if the null was true. You keep getting those, then you have a pretty certain idea that the null hypothesis can be rejected. Okay, it's always like, well, it might be 5% of a chance that it was just chance. It just happened. but you do it a few times, then it's really gets much, much lower than 5%. All right. So what is alpha then? If we're setting alpha and P is the probability of, whatever the probability is that you found something, we say P is 0.05 because we want it to be a 5% chance that you found something by random chance, nothing higher. We don't want to say, no, we're going to put P at like 0.6 because then it's a 60% chance that what you found, it was not the null hypothesis. And that's pretty not useful. And it's like, well, it's more likely that it is the null than not the null. So we want it to be a pretty slim chance that what we found was different from the null. We want to be pretty sure, pretty stringent about our standards in terms of seeing something scientifically. That's the idea. So alpha is the probability of a type 1 error, right? So 0.05, the probability is 5% that we've made a type 1 error. So when we say P equals 0.05, what we're saying is that there is a 5% chance that what we have is a false positive, that it was just random chance and it was actually not different than the null hypothesis. That's what alpha is, okay? The probability that the null is true, given the numbers that we got from our study. Okay, the probability the null is true given the numbers we got from our study. So, for example, if you look at the homework you did for lab 32, we looked at study 3. This was the study of the clumsy people who are being trained to balance, right? So the null hypothesis here is that the clumsy population that is training can't balance as long or can balance equally as long as a clumsy population without training. In other words, training makes no difference. If you're clumsy, you're clumsy, the training doesn't matter. So P is 0.05. P is the probability that training is not helpful. So what's the probability training is not helpful? We have to set that P level at 0.05 so that the results you get are either going to be more like the null hypothesis, or if they're different enough that there's only 5% chance that they are the null hypothesis, then we'll accept them as the alternative hypothesis, and we will reject the null. Okay, so then we're looking at beta. Now, I think beta is new for you. You have alpha, and the opposite of alpha is beta. Beta is the probability of a type 2 error. We did talk about this briefly as it related to power when we're looking at the study power. When you're looking at analyzing power for your study, what you're doing is you're looking at the alpha level and the beta level, and you have to balance those. Those are related to each other, so if one goes up, the other one has to go down. And so as beta rises, alpha falls. As alpha rises, beta falls. Okay, so beta is the probability of a type 2 error. What you're doing with the type 2 error, again, you're getting that false negative. You're incorrectly retaining the null. You're not, which is the same as to say is you're failing to reject the null. Incorrectly retaining, failing to reject a true null. Okay, so how likely is it that the test will distinguish the truth? This is where you need that powerful intervention. You need to make sure that your study is well designed in terms of internal validity. All of that contributes to power so that you can have the best chance you can of determining what the truth is. Okay, so here's a little graph that might help you. If HO, which is the alternative hypothesis, is, HO is the null hypothesis. If HO is true and you don't reject it, then you've made the correct decision, right? And that is correct. But if HO is true and then you rejected it, what happens is you've made an incorrect decision. That is a type 1 error. So hopefully this graph will kind of help you if you think more graphically or like a table than instead of words like I've used with chocolate examples. Hopefully this will clarify it for you. So if the null is false and then you don't reject it, then you've made a type 2 error. If the null is false and you do reject it, you've made the correct decision. Okay, hopefully that cleared up some questions for you. If not, you can. I've got the slides. They're on the announcement, ready for you to look at. They're in your files on Canvas. Or if that still doesn't work, feel free to email me. I'm happy to try and help you individually, or we can set up a phone call, something like that. Okay. All right, next thing I want to turn to is our survey activity. So you guys will have finished the surveys and posted them on the discussion board by Tuesday the 14th. And on that day, then what I want you to do is take other people's surveys. And so specifically, here's what I mean. Take 5 different surveys. This should be fun for you, and it should not take very long. Take 5 different surveys from any of the ones that are posted on that discussion board. Report your score on that board. Report your score so the person who created this survey can see it. And then also rate how accurate you thought the survey was for you. Okay, either 0, this is totally seemed not accurate, or 10, this is spot on. This really is a very accurate survey. Put that in a comment on the discussion board. So part 1 of this is you take 5 different surveys, you rate their accuracy, you report your scores, okay? And then part 2 is you take a look at the feedback on your survey. When you're looking at the feedback, part of what you're looking at are the scores people reported. So you want to look at those scores and then look at the scores that you thought would be a good representation of a norm based on those 4 people that we had talked about you including last week. And so think about that. What would you do to improve your survey? What are your thoughts? And what's a good criterion that you could use? So if you think about criterion related validity, like for example, let's say you give me a survey on depression, and then you want to see how accurate that was. You're going to measure it by a criterion. And so let's say your criterion is like the Beck Depression Inventory, which is a pretty standard, well-built, well-known scale that has good validity and reliability. And so that would end up being your criterion. Let's say your love of chocolate is measured by giving someone a choice between, let's say they could have 5 Hershey's bars or one really great, lovely piece of chocolate. And if they choose the 1 over the 5, then you'd think, okay, probably they're one of those people who really like their chocolate exclusive or, you know, high end or something like that. Versus the person who says, I'll take the 5 bars because more is better and I don't care about the quality. So that could be a criterion, another example of a criterion. So think about what's a good criterion that you could use. And I'll ask you those questions on this week's quiz. So you put part A, take your results from the 5 different surveys and your comments about those surveys on the discussion board. The second part here, the feedback for your own survey that you're going to report on the quiz that you'll take for this week. Okay, I hope this clarifies things. Take the extra time I'm giving you this week because we're ending lecture now. Take this extra time and spend it working on your draft. On Thursday, we're going to have kind of, again, a shorter version of a smackdown on a paper that is fairly awful. And so read that paper. It's on the announcements. I put it on this week's announcements again, so you don't have to go back and look for it. Read that paper. It shouldn't take very long. We'll talk about it on Thursday. Keep working on your paper, which I'll get on Friday. The quiz is on Saturday. All right. Hope that's all clear to some extent. So you're doing your reading, your lecture, your survey activity, taking the 5 surveys, providing feedback. You're doing your own personal survey thinking and reporting that on the quiz that's due on Saturday. You're finishing your paper for Friday. We're doing the smackdown on Thursday. Okay? I know. All right. Talk to you Thursday.